A fan that hums, starts slowly, or refuses to turn may have a weak run capacitor, but those symptoms are not a diagnosis. This film shows a safe decision process, not live electrical work. Before opening anything, locate the exact unit model and its authorized service information. If you cannot positively identify the circuit, isolation points, and required procedure, stop and use a qualified technician. In a compatible single-phase fan motor, the run capacitor works with an auxiliary winding to create the phase relationship that helps produce rotating torque. It remains in the operating circuit, unlike a start capacitor used only during starting in some other architectures. Never assume every AC fan uses the same arrangement. Confirm the motor architecture and capacitor type from the exact equipment documentation. The first test is not with a meter, it is a safe shutdown. De-energize and isolate every source that can feed the equipment. Apply the lockout, tagout, personal protective equipment, and qualified person rules required for the site. Then verify absence of voltage with suitable equipment using the locally approved method. A switch in the off position is not proof that the circuit is safe. A run capacitor can retain stored energy after supply power is removed. Follow the equipment or capacitor manufacturer's service method to discharge and verify it before touching terminals. Do not bridge the terminals with a screwdriver, the uncontrolled current can arc, damage the part, or injure the person holding it. If the approved discharge and verification method is unavailable, the safe result is to stop. With the equipment proven safe, identify before disconnecting. Record the unit model, motor model, capacitor label, terminal designations, mounting arrangement, and every required rating. Photograph the as-found installation only after isolation. Use the exact wiring diagram for that exact unit. A wire color, terminal pattern, or capacitor value found on another fan is not transferable evidence. Visual inspection is a screening step, not a complete test. A swollen case, leakage, burned connector, corroded terminal, or damaged mount is a reason to reject the part and investigate related damage. But a capacitor can be electrically out of tolerance while looking normal. That is why appearance alone cannot clear the component or prove the rest of the fan is healthy. For an isolated capacitance check, disconnect only as the authorized service procedure directs, keep the capacitor separated from the circuit, and use a suitable meter in capacitance mode. Compare the stabilized reading with the capacitance and tolerance printed on that exact capacitor or specified for that exact unit. This animation uses symbols, not a universal microfarad value. An in-circuit or energized reading is outside this workflow. Real Longwell motor material illustrates why model identity matters. A capacitor motor family contains different constructions and applications, while exact drawings can carry model-specific lead and dimensional information. The available drawings do not establish a transferable capacitor value. Treat every nameplate and wiring document as model-bound evidence. Never copy microfarads, voltage, tolerance, terminals, or wire colors across models. If replacement is authorized, match every field required by the equipment documentation, run capacitor technology and application, capacitance, tolerance, voltage rating, temperature class, life or duty class, terminal form, dimensions, mounting, and approvals. Never fit a lower voltage part, and never substitute a start capacitor for a run capacitor. When any field conflicts or is missing, resolve it with the manufacturer or a qualified supplier before installation. Installation quality matters as much as the label. Restore conductors to the documented terminals, provide the specified connector retention and insulation, secure the capacitor in its correct mount, route wiring away from moving or hot parts, and replace every cover and guard. Do not leave loose terminals, exposed connectors, improvised brackets, or bypassed protection. Follow the exact torque, enclosure, and reassembly requirements for the unit. If the capacitor passes, keep diagnosing. Supply voltage, controls, overload or thermal protection, bearings, a blocked impeller, damaged wiring, and motor windings can produce similar symptoms. Do not keep replacing capacitors to mask a mechanical or electrical fault. A useful service record separates symptom, measurement, evidence, corrective action, and controlled post-repair verification. The complete decision path is simple: identify the exact unit, isolate and prove it safe, control stored energy, document before disconnecting, inspect, test the isolated capacitor, match every replacement field, restore protection, and verify through the authorized startup procedure. Save this checklist for the next fan call, and if one safety or specification step cannot be proven, stop and escalate rather than guess.